Hello everyone. Very good afternoon. It's 3 o'clock, and yeah, I was kind of thinking of covering a bit of details about NXOS technology that we generally use. If you are a network engineer, you must be aware of Nexus. Well, in today's session, I'll be covering bit of basics about NXOS. What is NXOS? Why we would need it, and um, what are the features that it will be covering, and yeah, of course, and the details of the features will be explained in next sessions. So sit tight and please do focus on what are the details that I'll be sharing, and if you've got any issues or any questions, you can always shoot it in comment box. Thanks. Well, in this entire sessions that I'll be covering those peculiar and very important topics about Nexus. The first thing is like why would we need it? Demand of NXOS. The second is gonna be the hardware overview. The third one is gonna be the software version. Of course, we can use it as layer 2, layer 3. It's a layer 3. Um, of course, we've got the so-called access layer Nexus as well, which kinda comes up with the function of layer 2. We can use fabric path for ACMP. We can use it as a VSS the way we've got 6500 switches in which we can use VSS feature, wherein the entire, if you got two switches, three switches, you can combine it into a one logical switch. But over here in VDC, it's not like that. VDC is like you can break one switch into three different switches, four different switches, max to max. Of course, fiber channel over Ethernet. And then we've got VPC is nothing but virtual port channel. So aggregation of Ethernet links between two switches, and we'll be coming up with the keep alive link and peer links, and there will be load balancing, like you can actually use it to have one switch as active and the other one as standby, or might be active. And then we've got OTB, which is nothing but you can configure the overlay network over underlay network. So why do we need Nexus? We've got 3750, we've got stack switches, we've got 6500. 6500 is also serving the same purpose. What is nothing but the so-called purpose is nothing but like use of bandwidth utilization. If you got the bandwidth, if you got the good bandwidth, the utilization should be proper. So if you got the slots, the cards, you can use links of higher bandwidth like 10 gig. Because if you will be working in data center, of course it will be using higher bandwidth links. So that's the reason you will need Nexus. Like if you got the servers which might need 10 gigs, which needs the so-called bandwidth manipulation, in that scenario Nexus is the one which can serve the purpose. So the first thing is for higher bandwidths, for proper bandwidth utilization. Second thing is scalability. Third thing is redundancy. Fourth thing is low latency. Good point. for SAN OS, for the servers, for the storage, for the mail exchange servers, NXOS in the networking aspect, if you'll consider the networking aspect, NXOS is the best solution you can ever have. Of course, cause of scalability, cause of low latency, proper bandwidth utilization, high bandwidth, redundancy, no, the efficiency will be increasing, and the operations whatsoever the operations that we will be taking care of will become more simple. So if we'll consider the core layer, we can use 7K and 9K Nexus. In core, we can consider if you want to have iOS 6500. But if you want to have a Nexus 7K or 9K, in aggregation 5K, 7K, in access 2K, 1K. That's the fabric module. You can use hardware or software, whichever option is appropriate according to your requirement. So the so-called link requirement, it goes from 1 gig to 100 gig, 1 GB to 100 GB, like 1 gig to 100 gig. So according to that, we've got the slots and the modules in 7K and 9K and 5K. So what exactly the features of 7K, we've got 7000 series, 7700 series. So typically we will be using it in core and aggregation. Of course, high performance, density and availability. And it's not a fabric core, but a fabric core over Ethernet switch. It has got redundant power, line cards and supervisors. So zero service disruption, graceful system, integrated light out management, lossless fabric architecture. You can have 40 gig or 100 gig modules, unified fabric, 15 TB switching capacity, virtualized control, and efficient physical and power design. There are 7 form factors: 7018, 7010, 7009, 7004, 7718, 7710, 7706. In Nexus, we've got two cards, M cards and F series cards. M series cards are nothing but layer 3 cards. Those are the cards with features. F series card are nothing but the layer 2 cards, performance oriented cards. So M series will be taking care of routing, fax, OTV, trustsec. F series will be taking care of fabric path. It will be taking care of L2, VPC and FCOE. This is about the modules that we can have. 3 different modules. If you will aggregate the links terminating in these modules, you can use the bandwidth wisely. So this is about the SFP and transmission media. About 5K, typically end of a row aggregation. You can use 5K in aggregation layer. Some data centers, like small organization, can use 5K in core. Typically layer 2, but can do limited layer 3 with add-on daughter card. And of course, you will be adding cards to have more utilization, bandwidth utilization, to have more features. Yeah, of course, redundant power, but supervisors, no, we will not be getting supervisors. Um, First gen, second gen, Nexus 5000, second gen 5500. In 5000, you got 5010 and 5020. And in 5500, you got 5548 and 5596. 5500 can support L3 add-in card. So I've already mentioned that 5000 will be taking care of layer 2 functionality, but if we'll be adding cards, it can be used as L3, of course. Supports unified IO. 5500 supports unified ports. Ports can run as Ethernet or native fiber channel. Ethernet ports are located at port 1 and counts up. Fiber channel ports are located at last port, counts down. It requires a reboot to reallocate ports role. And that is for the unified ports in the 5500 series. So in 5500, you've got Ethernet ports and you've got fiber channel ports. So these are the modules. So if you want to have fiber channel, only fiber channel, it will be coming up with 8 ports, 1 or 2 or 4 gig. You want to have fiber plus Ethernet, you will be getting that 10 gig and 4 fiber port. We've got the 2 slots, 2 expansion module slots, including 40 ports, 10 gig Ethernet ports. So around 56 port layer 2 switch. Yeah, of course 2000 will be using it as access. It is called as fabric extender, acts as a remote line card. If you got a remote site, you can use that switch over there or in the data center itself, but then depends the remote site, in the sense few miles away from the main building. All management perform on parent switch, of course. It acts as a remote line card for 7K and 5K. No console on VTY ports. On fix, NXO is automatically downloaded from parent. No local switching. It's not an Ethernet switch. It's PR switch. It can impact design decision of platform placement. Traffic between local ports on fix must flow north via uplink to parent and the south back down. The software versions that we've got are Nexus V6.0, then we've got version 5.1, 4.2 and 5.2. The so-called basics about Nexus or Nexus OS on a Nexus OS is nothing but at its core it's a layer 2 layer 3 switch. Similarly, in many aspects to Catalyst iOS VLAN, it will be coming up with the features like VLAN trunking, VTP, rapid PVST, MST, VPC, like layer 2, of course, VPC, Ether channel, PVLAN, UDLD, FHRP. FHRP is nothing but VRRP, HSRP, GLBP. Then it will be covering IGP protocols like EIGRP, OSPF, EGP like BGP. The key new features beyond Catalyst or iOS, that the additional features will be VPC, VDC, Fabric Path, which I'll be covering later in the next sessions, FEX, OTV, FC switching, FCOE. About port channel, unlike iOS, we've got port. We can configure the port channel in Nexus as well, but it does not support PAGP. It supports LACP. So the command is gonna be switch port mode desirable. Before that, you have to enable feature. So if you're gonna use any routing protocol or any other feature like IGP, EGP, VPC, you have to always remember, you have to always activate that feature VPC, feature LACP. As I already mentioned, that we can break the switch into two or three different logical switches with different versions of NXOS, different control panel and data plane, data control plane and data plane. uh, Unlike iOS, NXOS does not support PVST plus and CST. Of course, the default mode is going to be rapid PVST plus, rapid STP, that is 802.1W. It also supports 802.1 S MST. We've got the three different port types, that those are normal, edge or network. So spanning tree port type, normal, edge and network. Bridge assurance is something wherein no matter whatsoever the STP port state you've got, the ports will be forwarding BPDUs. So it's gonna replace the so-called loop card functionality. You can do VTP pruning type stuff. So VLANs will stop forwarding on trunk links. You can use this command to have bridge assurance. The so-called layer 3 functionality, you have to activate the feature of interface VLAN. The routing protocol you will be covering, you can use IGP and EGP. The policy routing, route maps, prefix list. The way we generally use in MPLS, the VRF concept. We can configure VRFs. The for redistribution, like if you got the routing protocol, you want to have redistribution of the routing, you can always come up with the route map, match the logic and set the logic. But unlike iOS, route maps are required to perform redistribution, but redistribution does not include directly connected interfaces. So you directly redistribute, it requires redistribute direct route map rather than assigning the so-called route map to the interface. So in this session, I'll be covering very important point about VDC, a very important feature, key feature about Nexus, which is nothing but VDC, virtual device context. So what is VDC is nothing but, if you got the two switches, you can break it and you can come up with four different switches with different data planes and control planes. It will be taking care of different logical rules. Some features you can't add in the same VDC, which is nothing but F2 cards. FCOE requires its own storage and OTV. So if you got a SOUP 1 module, 4 VDCs, SOUP 2 4 plus 1 and SOUP 2E 8 plus 1. There are 4 different types of VDCs: default, admin, non-default and storage. Admin VDC is the VDC which will be taking care of management, like creating VDC, deleting VDC, management of the VDC, creation, suspension, deletion, interface allocation, VDC level security. It will be managing the license. You cannot perform the L2 L3 features. You have to get into that VDC and then come up with any kind of functionality that you would like to implement. You call it L2 or call it L3. So this is something which will be nothing but for management purpose. Default is the one which will comes up with the switch by default, which is nothing but the default VDC1. You cannot remove that. You can create and manage using that. Use that to create and manage other VDCs. You can allocate the ports. It is used to manage the chassis. So those are the some tasks which are listed in this slide. As usual, VDC creation, deletion, suspension, resource allocation, Nexus OS upgrade across all VDCs. Then you got ISSU or EPLD upgrade. You can install the feature set for Nexus 2000. Control plane policing, port channel load balancing, hardware IDS check control, access list capture feature enable system wide QoS. Non-default, it is used for the daily production traffic. This type of VDC is said to be fully functional and has all capabilities. Any changes which is done on any non-default VDC is applicable to that VDC only. Each non-default VDC has its own discrete configuration file. So it kind of runs its own set of L2 L3 protocol for VDC and thus provides fault isolation. So if you're gonna come up with the different VDCs, if you're gonna create the VDCs using admin or default, those VDCs are gonna be used for the daily production traffic. So those will be called as non-default. In this VDCs, you can run the L2 L3 protocols whichever whenever needed according to your requirement or company's requirement. Storage VDC, of course, for the storage purpose for SAN OS. Will need FCOE fiber channel over Ethernet license, FCOE license to create storage. We've got 4 different roles: network admin, network operator, VDC admin and VDC operator. So it's called as role based access control. for the user who will be taking care of VDCs. Network admin can create, delete. Operator, read only access. Admin is something full control over the particular VDC. Like the VDC admin is nothing but for that particular VDC, which will be assigned to that user, whichever the respective user will be having full control over that VDC for that particular VDC. Operator, again, read only. So network admin is the one who can create, delete, can issue the read-only commands, can perform the changes, can implement the changes. Operator will be only issuing read-only commands, will be fetching all the info. VDC admin will be the one who will be having control over the so-called provided or given VDCs from the network admin. It can only take control of the respective VDC which has been allocated by network admin. Operator will be having read-only access. There are three types of resources. We've got global resources, dedicated and shared. Global resources is nothing but boot image and the so-called software version and COPP. And we've got the dedicated resources, L2, L3 ports, VLANs, IP addresses, shared OOB management port, Ethernet management port. The number of Cisco VDC that we can create on Nexus Switch depends on the supervisor model. SUP1 model, SUP2 and SUP3. As I already mentioned in the earlier slide, that you can create 3 non-default VDC, 1 default, or 4 non-default and 1 admin. Default is gonna be there. You can't delete that. So when you'll be creating 4 non-default and 1 admin, which means in default VDC you'll be coming up with the admin VDC. You'll be using admin VDC to create 4 non-default. Similarly for SUP2 and SUP3, SUP2E. So let's say I've got 7K switch 1, 2, 3, 4, and 7K 1 is the default, 3 and 4 are non-default. Which ports that will be allocating, it's mentioned in the table. We will be coming up with 2 templates, OTV and switch template. So once you'll be configuring the VDC, configure 7K3 from default. I mean, you have to switch to the VDC which you have created with the management port that you have assigned, and of course you will be assigning the gateway. So from default VDC, you have to issue command VDC resource template OTV template. You have to limit the resources, how many VRFs you can configure, minimum, maximum, VLANs, port channel. Then you've got the switch template, how many VRFs, VLANs, port channel. So under VDC N7K1 ID1, you will be assigning the template, the policy, single supervisor reset, system reset, and then you have to limit the resources and allocate the interfaces. Okay, the so-called usage of the so-called command that we will be issuing over here in N7KID1. That is nothing but system hap reset. I will be coming up with the details about this particular command in next session. Now, my main question about those two different templates that we've got is nothing but the OTV template and switch template. We are issuing the three different commands, but the same commands, I mean, are very similar, almost the same number, except for the port channel. And we are applying that template to only default VDC. I mean, not default, the admin VDC, and the other templates we are assigning it to the other VDCs. So N7K1 is the default VDC. And you can get into that VDC by issuing command switch to VDC N7K3 from N7K1. And then you can assign the management address on the gateway. So thus you can create VDCs and allocate resources. But if you wanna, sorry for the disturbance cause. If you wanna know more um, about the commands that we have used in creating the VDC, we can always search serve. And we've got the same output like VDC red and then ID1, and you can issue basic commands like show VDC, show model, show VDC. But the command which we have used to create the default VDC system app reset, let's check the usage of that. Okay, that is the command you generally use to configure the switchover and reliability. So enable the supervisor reset reliability. So in default VDC, you will be issuing that command to enable the reliability to get back to the factory default. Might be in next session I'll be covering most of the part related to hireability, how we can configure the hireability in VDCs. I'll be covering the details about it. But yeah, uh, till now, for today, whatsoever the details that I've covered and whatsoever the information that I've covered, I think for beginners is kinda more than enough as a part of introduction and the main feature that I've covered about VDC. In next part, I'll be covering how we can configure this. This was a basic, but in details, and you can issue some commands to verify the VDCs, and of course about the hireability and the other stuff that you would like to know how we can configure, as in terms of VDC, not in terms of Nexus I'm talking about, and the commands that we'll be using in the next session. Thanks anyways. Take care. That was all for today. Thanks a lot.